Okay, we had a equals problems here today. Y equals AX plus B, solve for X. Everybody got this, didn't write it out exactly the way I prefer you do, but you didn't make a mistake on it, so it's okay. But I'm gonna write it out the way I write these out. You got Y equals AX plus B. You're gonna subtract B from both sides. So you're gonna write Y minus B equals AX plus B minus B. B minus B is 0, leaves you with AX. And here you got Y minus B. I'm gonna do an extra step and switch sides. And then I'm gonna take AX and divide by A and Y minus B and divide by A. In other words, I'm gonna divide both sides by A, and it's gonna give me X equals Y minus B over A. I think everybody got that. So that's a good start. Okay. Now the second one, we've got some symbols. Not everybody read the symbols the same as I did. And I think it's pretty clearly written, so, if you misread it, you actually made it a little bit harder, but that's harmless. I can still see if you know what to do. Now that's a Q in front of X. It's P times quantity QX minus C. All right. You've used the distributive law. A P out here in front of something with all these parentheses in it means P is multiplied by this, and P is multiplied by this with a minus sign. Okay. So we write this as Y equals P times QX minus P times C. So that I'm having trouble writing down here. So let's see. I'm just going to bring it over here. So it's Y equals PQX minus PC. We add PC to both sides. And now we've isolated X. Now switch sides, we got PQX. I'm having trouble writing that Q down low. Should have chosen a different letter. Okay, so we're going to divide both sides by PQ. And then the PQ here divides the PQ here. X equals Y plus PC over PQ. So basically, the step that it tends to confuse people is this distributive law. We got to make sure we understand and know how to use the distributive law. And it's simple enough. The reason for the distributive law is simple enough. Let's do this. Why the distributive law? Well, we can test it. We can use some numbers. What's 2 multiplied by 3 plus 4? Well, that equals 2 times 7, which is 14. And that's no problem, but that's also equal to 2 multiplied by 3 plus 2 multiplied by 4. It's 2 times 3 is 6, and 2 times 4 is 8. And that adds up to 14. Same either way. So you have to have the distributive law. If I write 2 with the parentheses here, well, if you follow the order of operations, that is 2 times 7, which is 14. And you wouldn't necessarily do this, although it wouldn't be wrong. If you follow the order of operations, you're just going to add the 3 and the 4. And you're not going to do this, but if you did this, you'd still end up with the correct answer. Okay, the 2 has to multiply both the 3 and the 4. And if I multiplied 5 times 6 minus 3, that would be 5 times, let's do 6 minus 2, 4, 20. 5 times 1 is 6 minus 2, 6 minus 2 is 4 times 4. 5 times 4 is 20. Does it work if I use a distributive law? Yeah, that's 5 times 6 minus 5 times 2, which is 30 minus 10, which still equals 20. It's always going to work. Now, if you do it with symbols, if it's z times k plus r, that has to equal whatever z, k, and r, whatever the values of z, k, and r, it's got to be the same as if you do z times k plus z times r, because that's the way it works. It always works. You put any numbers in here, and if you're not convinced, you should put numbers in there until you're convinced that it always has to be true. 2 times z times k plus r is z times k plus z times r. M times n minus p is m times n minus m times p. Now, if you have more terms, if you have a times rs minus p over, why not p over 7? It doesn't have to be a number there, it could be a symbol. Sometimes you have a combination of numbers and symbols. As you know, since you've seen it, you have a times rs minus a times p over 7. Now that simplifies a little bit. It's a p over 7, but there is the distributive law. It always acts the same way. And I did notice that some people had a problem at a certain point on the assignment and linear functions. So and sometimes that came back to distributive law. Okay. If there are too many distributive laws in a function, people tend to get the wrong answer. So we'll do one like that. Okay, but first, the biggest problem people had, not everybody had a problem with it. The people who did have problems, almost all had problems on this one. So let's look at this one. We got denominators. Now, I don't know why I have such a hard time convincing people of what I've already said several times, which is that if you have denominators in an equation, you multiply by a common denominator. Okay, so write down that equation, and I'm going to ask you if you can just write down what is a common denominator that you want to use. Any common denominator is fine, but the smallest common denominator, or what we call the least common denominator, is generally the easiest one to use, so it's the one we generally try to use. Okay, everybody's wanting to put 15 down as in their denominator. Okay, well, you can't, I mean, you can do that. you could multiply the numerator and denominator here by 5/5, and you would get 5x over 15. And you could multiply the numerator and denominator here by 3/3, and you get 3x over 15. That's not what we're doing. We do this with fractions because we don't want denominators. We don't want a denominator of 15. We find the common denominator, which everybody found correctly is 15. Now, I said, let's multiply both sides by 15. What do I mean by multiply both sides by 15? I mean, multiply 15 by x over 3 minus x over 5. 15 multiplies the whole left-hand side. And 15 multiplies y plus 2. So that's the critical step. Okay, you found the common denominator. I think you'll often be okay doing that. Sometimes it gets a little tricky. And remember, I believe we did go over the whole thing about least common of using prime factorizations to find common denominator, and Open Math did too. So sometimes you need to use that. But right now, I'm just concerned with how we use the common denominator to solve an equation. Make sure you review the addition of fractions, but I think you've kind of pretty much done all right with that. Okay, so what do we get? Let's see what you got. Okay, now people are having a little trouble figuring out what to do with this. Well, here's a distributive law, remember? If we got something multiplied by something minus something, we multiply this by this, we multiply this by this, and there's a minus sign in between. Okay? So to multiply this, it's the same pattern. We multiply 15 by x over 3. And then minus 15 times x over 5. That's what we get on the left-hand side. What do we get on the right-hand side? Yeah, one other comment is you don't stop and worry about how you're going to multiply 15 by x over 3. Not at this step, that's the next step. In this step, you just multiply 15 multiplied by this, there it is. Then you do 15 times negative x over 5. Well, negative 15 times x over 5, and you get this. Now here you didn't worry about how you're going to multiply m by n because it's symbols. Okay? You didn't worry about the fact that, well, maybe something's going to simplify in the next step. You take this step, one step at a time. So we do 15 times this, minus 15 times this, there it is. What are we going to do on the right-hand side? Now, as I expected, everybody got the right-hand side right away. It's 15y plus 15 times 2. Now, how does the right-hand side simplify? Well, you got 15y, which doesn't simplify, and you got 15 times 2, which does. You got 15y, it's a little simpler to write 30 than 15 times 2. In other words, you do the multiplication. Now, what are we going to do with, how are we going to multiply 15x over 3? Well, to understand what's going on, rather than do something by habit, we do what we know to do. When we multiply two fractions, we multiply numerators and we multiply denominators. First, we write this as 15 over 1 times x over 3 and 15 over 1 times x over 5. So that we have 15x over 3 minus 15x over 5. Is that clear? Make sure you understand that if I multiply 15 by x over 3, I get 15x over 3. And understand why. Because we can write 15 as 15 over 1 and use the rule that we know for multiplying fractions. There's no magic shortcut to understanding that. Now, there's something we can do out of habit. Okay, but I'm not even gonna talk about that. It's easy enough to think, let's make these both fractions and multiply the numerators and multiply denominators. Okay. Now, the step that I don't like to do, but I'm gonna go ahead and do it because I find that people don't understand it one way or the other, so we're gonna stick with the usual explanation is, well, I'm just gonna say, 3 divides into 15 5 times, right? So this is like 15 over 3 times x over 1, but anyhow, the 3 will divide the 15, and 3 divided into 15 is 5. And 5 divided into 15 is 3, so I get 15x minus 3x equals 15y plus 30. Now you see, by the magic of multiplying by the common denominator, I don't have fractions to worry about anymore. And that makes things a whole lot simpler. So go ahead, write down those steps, make yourself a few notes if you need to, and then see if you can now solve for x. Okay, so that was good. What's 5x minus 3x? It's 2x, right? You got 5 of them, you got subtract 3 of them, you got 2 of them. You divide 2x by 2. You have this, which is then just going to give you x equals 15y plus 30 over 2. Okay. Now we'll make a note. That's an okay solution. But sometimes when we get into linear functions, which we're going to be getting into soon, in the world, Zoom keeps freezing up, so I can't tell where the left side of this board is. I think it's still recording all right, it's just not displaying really well. Okay, behave a little better now. Okay. So x equals 15y plus 30. Over 2. Well, you have a distributive law for division as well, because division is just a multiplication by fractions. So this equals 15y over 2 plus 30 over 2, which equals, I'm going to write it this way, 15 halves times y plus 15. So you want to think about that a little bit. I'm not going to emphasize it right now, but it's going to come up when we try to do linear equations. Okay. Now, if you were solving this equation for y, you would do everything the same down to here. But then you'd subtract 30 from both sides and divide by 15, wouldn't you? Okay. So if you're solving for y, that doesn't change the fact that you want to multiply by a common denominator. You don't want denominators when you solve for y any more than you do if you want to solve for x. Okay. So when you see a fraction with denominators, get the heck rid of them, right? They're in your way. They make it harder. You got to deal with fractions. You got to add and subtract fractions. You don't want to do that when you don't have to. Sometimes you have to, of course. But when you're solving equations, you don't have to. Make life easier on yourself. Okay. right? Okay. Okay. What's the absolute value of -4? Can you tell me? Yeah, well, okay, have you seen absolute value? Well, it's a pretty simple idea. The absolute value of a number, I'm going to introduce it like this. Here's a number line. Here's 0. Here's -4, right? How far is it between these two numbers? 4, right? If you had to go from here to here, you'd have to go 4 miles, let's say. Okay, so this is, well, whatever. From here to here is 4 units. From here to here is 4 units. That's the distance. Okay. Absolute value of -4 is its distance from 0, and distance can't be negative. Just plain old distance. It's how far. Displacement is the thing that can be negative. The displacement displacement from 0 to -4 is -4. Okay, if you go from 0 to -4, you're going in the negative direction. Displacement can have a sign on it. Displacement has a direction. Now, the displacement from 0 to 4, if you want to go, from -4 to 4, displacement from negative, I'll say it right in a minute. Displacement from -4 to 0, from here to here, we would go this way. Okay, so if you want to know what direction you're going in, you talk about displacement. Displacement includes direction. Distance doesn't have a direction. Distance doesn't care if you're going from A to B or from B to A. Okay, well, that's an important connection. That's an important part of the whole idea of absolute value. Now, the definition is a little more complicated, and I'm not even going to talk about the definition of absolute value because it's a little bit formal, but we kind of need that too. So I'm going to leave it to open math to give you that definition. Okay, so we're just going to learn how to work with it. The absolute value of -4 then is 4. Okay, and the absolute value of 4. And let's complete the thing. Distance from -4, between -4 and 0 is 4. And the distance between 0 and 4 is 4. So this is 4 and this is 4. Okay, so that's not difficult. If it's a negative number, you just make it positive. Okay. Now we want to look at an equation. equation is absolute value of x minus 5 is 4. Now, what's the absolute value of x minus 5? Well, you don't know because you don't know what x is. There are two numbers that make the absolute value of x minus 5 equal to 4. X minus 5 can be 4, or x minus 5 can be negative 4. Okay? Because whatever's in the absolute value sign, whatever's between the absolute value signs has to have an absolute value of 4, so it's got to be either negative 4 or 4. Okay. I think I just kind of said the same thing twice. Let's think about this one first, and this is really what I should have started with. So absolute value of x equals 4. X can be 4 or x can be negative 4, right? Well, if the absolute value of anything is 4, then that anything could be either 4 or negative 4. Now, I recommend that you write it like this. Over here, you write x minus 5 equals 4. Over here, you write x minus 5 equals negative 4. And in capital letters, you put or there. Does that say the same thing I said up here? If the absolute value of something is 4, that something could be 4, or it could be negative 4. That's the key idea that you want to start with when you look at absolute value equations. Excuse me. So we can solve this equation. This one's easy to solve. And you get x equals 9. Just add 5 to both sides. And add 5 to both sides here. And you get x equals 1, not negative 1. Okay. We check something you always need to do and something you probably aren't doing as much as you ought to. Okay. You learn a lot better when you check things. You retain it better. Because every time you check it and it works out, it reinforces what you did much better than just open math saying, yeah, that's right. Okay. You figure out that it's right. And you tell open math what you think, and if it's wrong, you fix it. You learn faster and better that way. Okay, so anyhow, we check. Absolute value of 9 minus 5 equals the absolute value of 4, which is 4, right? In other words, we substitute x equals 9 in here. And let me do what I usually do. Throw this here. Bring this up into the equation. And it comes around. It's going to give me two things, one here and one here. So I take the x equals 9, and the x equals 9 is what I'm actually substituting. So let's make sure I know what I'm starting with. X equals 9 goes into this. And I get this. And x equals 1 can go into this. Not sure how I'm going to get there. So I'll just draw it myself here. join up with this path. So x equals 1 goes up in here. It also gives me a result. Okay. So if x equals 1, I have an absolute value of 1 minus 5 equals absolute value negative 4, which equals 4. Both values plugged in here give me 4. Now I know I got it right. If you do this, you're going to think about it in a way a little different than you did when you went through the equation. And pretty soon you're going to understand exactly what to do when you see an absolute value equation. Okay, well, let's solve a couple more because they're not all this simple. Let's try. I'll use 4. Okay. We're comfortable with 4 over there, but it doesn't matter what number I put over here. It should be clear what to do. Okay, so write this out like I did here. Write the steps the way I illustrated them. Okay, now at least some people just went ahead and wrote this down without the absolute value signs and went ahead and started solving it. It's not what I did. Okay, I did write it without the absolute value signs, but then I wrote it over here again without absolute value signs, but with the opposite sign on the 4. And I put the word or in here. That word or is important. Logic of this is important. That might not be clear right now, but soon enough, we're going to get to the logic of or versus the logic of and we want to be sure we understand this is an or. Then we'll understand why I say this is important, okay? So I want to see that word. Okay. Now, we split this into 2 equations. 2x plus 6 equals 4. Or 2x plus 6 equals negative 4. Why don't I say this and this? Because I did write this and I wrote this. Well, logically, it can't be, x can't be the solution to this equation and the solution to this equation. It could be the solution to this equation, or it could be the solution to this equation, but it can't be both at once. My solutions here are 9 and 1. X can't equal 9 and 1, right? Now, the confusing thing is when you put your solution set down, then you put the 9 and the 1 in it. So it gets, you know, the terminology can be a little confusing, and we want to get that straight at the very beginning. Anyhow, we solved this, okay? And I'm not going to write out the solutions. It takes time and everybody can solve it. We get x equals negative 1, or x equals negative 4. No, negative 5. Okay, I just did that by inspection, but if I subtract 6 from both sides, I get negative 10. Divide by 2, I get negative 5, right? If I subtract 6 here, I get 2, and divide by 2, I get negative 2. Divide by 2, I get negative 1. Then we check. Absolute value of 2 times negative 1 plus 6 equals absolute value of negative 2 plus 6 equals the absolute value of 4, which equals 4. So if I plug negative 1 into this equation, this is what I get. I can say if x equals negative 1, we get this, and that checks out. X is negative 5, we get 2 times negative 5 plus 6. Absolute value is absolute value of negative 10 plus 6, which is the absolute value of negative 4, which equals 4. Check. Both ways, we get 4. It worked. All right. Okay, well, we're gonna. Look at another example. What about this equation? Now notice that this equation is something a little different. It's not in this form. Okay. We have to have the absolute value equal to something. Nothing else, no multiplier, nothing added to the absolute value or subtracted from it, just the absolute value equals, okay? So how do you get this to the form? Can we find out what the absolute value of 5x minus 3 would have to be equal to? Well, we can do that. We could add the same thing to both sides, subtract the same thing from both sides, multiply both sides by the same quantity, divide both sides by the same non-zero quantity. Okay, so that's 4 things we can do. How do we do those, some of those 4 things to get from here to just plain old, the absolute value expression isolated on the left-hand side? So one thing I often see is something like this. Got absolute value of 2x equals 4. You just subtract your 6 from both sides, and it looks like that 6 goes away. Well, it doesn't go away. It's inside the absolute value signs. Okay, it's part of something that can either take the value plus 4 or minus 4. And if you do this equation, the one we have here, you not only don't get the right solution because you plug it in and try to check it and it doesn't work, you get something that doesn't even have a solution, because if you would get absolute value of 2x equals -2. Well, this would say that there's no solution, because the absolute value of something can't be negative. Okay? So you just can't do that sort of thing. Okay, and that 6 is sitting out there as a term in the equation rather than the term inside something you're doing something to. Okay? You can't do that. So try to convince yourself that you just can't do that. If it was 5 times the quantity 2x plus 6, you wouldn't be able to do it either. Okay, you gotta only do that to terms of the numerator or denominator, terms of the left side or the right side. Okay, so what we do here is we subtract 6 from both sides. You're gonna have 6 minus the absolute value of 5x minus 3 equals 1 minus 6, which means that then minus the absolute value of 5x minus 3 would equal -5. Here, can you see that okay? Tell me if you can. Because in about 10 seconds, I can erase that and write it a little bigger. Or just cross it out and write it a little bit. And I didn't write it out correctly. Didn't put my -6 on this side. Okay, so now got a -6 on this side, I've got a -6 on this side. 6 minus 6 is 0, so I get negative absolute value 5x minus 3. 1 minus 6 is -5, so I get negative 5. Now, how am I going to get the absolute value of 5x minus 3. Well, I don't really have room to do that step. If that's sitting there, so I'm gonna get rid of it. That's what we're after. We don't want a negative absolute value of 5x minus 3. We multiply both sides by -1. Which of course changes the signs. So you can kind of shortcut that. You can always change the signs of both sides, but that's a result of the fact that you can multiply both sides by -1. And when you multiply by -1, that changes all your signs. Well, it changes the sign of every term. Okay, then we can split this off. We get 5x minus 3 equals 6, or 5x minus 3 equals -6. And then we solve this. We're going to get x equals 9/5. Or x equals -3/5. I'm not going to draw my arrows and stuff. But if I plug 9/5 in where x is, this equation then becomes this. 5 times 9 over 5. Well, it's the same as 5 over 1 times 9 over 5. That's 45 over 5 if you like. Well, that's 9. Okay. And you can really think that this 5 is divided by this 5. You get 6 minus the absolute value of 9 minus 3. I did something wrong in my solution. I don't see what it is. I didn't write my equation right. -1 times -5 is 5. I must have seen the 6 corner of my eye or something. But that changes everything. Okay, now I get 8/5. And I get, I think it's going to be -2/5. Okay. So, sorry. Okay, hopefully that's legible. I get 8/5, -2/5. And now if I do it, I get 6 minus 5 equals 1, which checks. And then I get 6 minus the absolute value of 5 times -2/5 minus 3 equals 1. And that's going to give me 6 minus the absolute value of -2 minus 3 equals 1. 6 minus absolute value of -5 equals 1. So that 6 minus 5 equals 1. And that also checks. So you plug it in and work it out. And you might have a little bit of trouble working some of them out. But you just apply the rules. If you don't get it to work, figure out where you went wrong. Still can't get it to work, bring it to me and tell us next time, or take a picture of it and send it to me. I'll help straighten you out, okay?